Let's try to understand how to solve problems with two variables involving position and time. Question is, flight of 3000 km against the wind takes 6 hours and with wind the same distance is covered in 5 hours. Determine the wind velocity. Now this problem involves distance, speed and time. So when you get a problem like this, first thing is to recall the relation between distance, speed and time. So our triangle can represent it. Remember this triangle, it is very important. So this triangle, we can write distance on the top and speed and time here. It really means that distance is equals to speed into time. So let me write. So that means distance is equals to speed into time. And if you want to find what speed is, then speed is distance divided by time. It comes distance over time. And time could be written as distance over speed. So that is how these three quantities are related. So we call this distance, speed, time triangle. Easy way to remember the formula, right? So a visual look at this triangle will always give you the relationship. The second part which I want to show you here, which will again help you to solve any problem like this, is kind of placing the data in tabular form. So let's create a table. Here I am making a table with columns, and each column will represent distance, speed and time. Let's say this is distance, this is speed and this is time column. Now in this problem, distance is given in kilometers, so let's write kilometers, the unit for distance here. Speed will be in kilometers per hour and time is given in hours. So we have distance, speed, time here. Now we are translating the given information in the statements in tabular form. Let's read the question. Flight of 3000 km against the wind takes 6 hours. So we are given 3000 kilometers is the distance. Time taken is 6 hours. And against wind, let's write against wind for the time being. Now what is the speed? So we don't know the speed here, right? So what we will do is we will define some speed and then correlate. Now let's read the question further. Determine the wind velocity. So we are talking about a flight, that means an airplane, and we want to find wind velocity. That means there are two velocities involved. One is the velocity of the airplane and another one is the wind velocity, correct? So let's define variables for these two velocities and then we'll figure out what is the velocity against wind. So we use let statement. So let velocity or speed of airplane be, let's say A, and of wind be, let's say W. So we have defined two variables here with the let statement, which says let A be the velocity or speed of airplane and let W be the velocity of wind. Now when we say against wind, that means airplane will go slower by W units, right? Because wind is against the speed of the plane. So we can say, well, the speed should be A minus W. So that gives us speed against wind. Now the second part of this is, and with wind the same distance is covered in 5 hours. With wind, so let's say with wind. With wind, same distance, 3000. The velocity should be more because wind is going to help the plane to move faster. And therefore, it takes less time, 5 hours. Makes sense, right? So that is how we can translate the given information in tabular form. Now we have table here and formulas there. These two things can help us form equations and solve for the variables. There are two variables, the speed of airplane and the speed of wind. Now how can you relate them? We know distance is speed into time. So let's write down both the equations. So our equations are from here, 3000 is the distance, right? So we have 3000 equals to speed into time, so which is 6 times a minus w. And from the second equation, we get this second equation, 3000 equals to 5, which is the time times speed, a plus w. Correct? So we now have two equations, equation 1 and equation 2. So these are from the two rows. The first row, which gives us against wind information, and second row, which gives us with wind information. Now, using these two equations, we can solve for two variables. So as a first step, let's divide left side by 6 and 5 and simplify it. So what do we get? So 3000 divided by 6 is 500. So from here, let me write it down. So we have 3000 divided by 6, which is 500, equals to a minus w, right? And from here, we'll divide this by 5 and we'll get 600 equals to and we get 600 equals to a plus w. So that becomes our equation number 3 and 4. Now, with these equations, can you solve for a and w? If we add 3 and 4, what do we get? We get 2a equals to 1100. W gets eliminated. And so we can find the velocity of the airplane. And if we subtract, velocity of airplane gets cancelled out or eliminated. And we get an equation with 2w equals to 600 minus 500. And we can find the wind velocity. The question here is, determine the wind velocity. So let's do this. So what we will do now is, we will subtract from 3, we'll take away equation 4, right? And then write down our final equation, which will be 600 minus 500 is 100 equals to a minus a is 0, and w minus w will be 2w, right? So from here, what is wind velocity? Wind velocity is 100 divided by 2, correct? So we get our wind velocity from here, which is 100 divided by 2 equals to w, which is equals to 50. And therefore, we can write down our answer, which is wind velocity is 50 kilometers per hour, right? So that is how we are going to solve such problems. Now related problems could be a boat in a river, speed of the boat and speed of a water current will be a similar problem, right? So you can get many cases where airplane and wind, boat and water currents. So when these factors are there, you can adopt this method and solve the problem using two variables as we discussed. I hope you find it very helpful. Thank you.